following are the different port roles in common spanning tree. The root port is the interface on a switch with the lowest root path cost. In other words, in terms of cost, it is the closest to root switch. There is only one root port on a switch. A designated port is the interface on a link with the lowest root path cost. Now, whole switch is not considered here, but the link. That is, the connection between an interface on one switch and an interface on another. The last port role is blocking. A blocking port does not forward frames. Let us discuss tiebreakers in the next slide. There may be ties in selecting root bridge, root port, or designated port. That is, the measures used to select them are equal. They are tied. In case of ties, selection is made in the following order: lowest root bridge ID, lowest root path cost to root bridge, lowest sender bridge ID, and lowest sender port ID. This selection is conditional. That is, if the tie still exists after selecting option 1, select option 2, and so on. The election of root bridge and assignment of port roles require communication among the switches. This is accomplished through Bridge Protocol Data Units, BPDUs. Let us understand BPDU in the next slide. Bridge Protocol Data Units, BPDUs, help switches to communicate with each other. BPDUs contain many fields. The most important fields to share with other switches are as follows. The first is root priority. The next is root ID, which is the bridge ID of the root bridge. Another important field is root path cost, which is the cost of reaching the root bridge. The fourth is bridge priority, and the fifth field is bridge ID. BPDUs are sent on a periodic basis. This uses a timer. In fact, there are 3 timers used in Common Spanning Tree Protocol. Let us discuss timers in the next slide. Following are the timers used in Common Spanning Tree Protocol. The hello timer determines how often BPDUs are sent to adjacent switches. This defaults to 2 seconds and can range from 1 to 10 seconds. It can be configured with the command shown on the slide. The second timer tracks the max age time. It is the maximum length of time a switch port saves configuration BPDU information. If a switch does not receive a BPDU from its neighbor before the max age time, it will assume the neighbor is down. Max age defaults to 10 times the hello time. The third timer tracks the forward delay time. This is the number of seconds spent in the listening and learning states. This defaults to 15 seconds. In the next slide, let us discuss the port states. Ports can be in one of the 5 different states. Each port transitions through these states in an order. For example, to reach the forwarding state, the port must pass through disabled, blocking, listening, and learning states. The first port state is disabled. In this state, the port discards data frames received on the interface and switched from another interface for forwarding. It does not learn MAC addresses and receive or process BPDUs. The next port state is blocking. This state has all the same characteristics of the discarding state, except that the port receives and processes BPDUs. Now the port moves to the listening state. In this, the port not only receives and processes BPDUs, it also transmits them. The transition from listening to learning takes 15 seconds. The port is now in the learning state, where MAC addresses are entered in the MAC address table, meaning the switch learns addresses on that port. The transition from learning to forwarding takes another 15 seconds. Forwarding is the last port state. The port receives and forwards frames. It also forwards frames switched from another interface for forwarding. Ports can transition in reverse order as well. For example, a forwarding port can move through learning and listening to reach blocking. In the next slide, let us focus on common spanning tree processing.